applause to show some enthusiasm. Take it away, Frank. Thanks.
Hi, good morning. So I'm Frank. I'm actually really thrilled and also slightly nervous to be the first speaker of the day. I've had the opportunity to meet some of the other speakers before this event today as well, and I think we're really in for a treat. There's going to be some really amazing talks, and I think later on we'll even get to see and even try some amazing new technologies. So personally, I'm very much looking forward to that. As I was introduced, it's true, I'm a product designer and an artist, and I'm based in Arnhem. In my work, I try to work with the more complicated aspects of new and emerging technologies, like the social, ethical, and economical implications. However, today, I'm not actually going to talk about my own practice or my own work, because I thought, as the first speaker of the day, it would be more interesting to kick off with some general reflections on the theme, which is where digital meets physical, or where physical meets digital, depending on your own point of reference. So in this talk, I hope I can raise maybe a few interesting questions, and even possibly provide a little bit of a critical framework for us to take into the other talks of the day and in the rest of the day, so that we can discuss them afterwards maybe a bit better. Yeah, so that's what I'm going to talk about. And as I said, my background is in product design, so I thought it would be a very good starting point for me to start with something that I'm supposed to know well, which is the home, or more specifically, the living room.
For a moment Vashti felt lonely. Then she generated the light, and the sight of her room flooded with radiance and studded with electric buttons revived her. There were buttons and switches everywhere. Buttons to call for food, for music, for clothing. There was the hot bath button, by pressure of which a basin of imitation marble rose out of the floor, filled to the brim with a warm deodorized liquid. There was the cold bath button. There was the button that produced literature, and there were of course the buttons by which she communicated with her friends. The room, though it contained nothing, was in touch with all that she cared for in the world.
So The Machine Stops is a cautionary tale that was written by E.M. Forster in 1909, and please note that date, 1909. This is more than 100 years ago. And in this story, Forster paints a bleak future for humanity living with technology and living with machines. And as such, he became a forerunner in a genre of science fiction that talks about the loss or the enslavement of humanity at the expense of the machine, at the cost of the machine. However, what makes this story so disconcerting to read these days is that basically the environment that Forster is describing is actually quite similar to the living environments that we experience at the start of the 21st century. Our lives too have become increasingly augmented with all kinds of different technologies that are promising to make our lives more comfortable, more fulfilling, and above all, more easy. So it makes you wonder, like, to what extent are the anxieties that Forster is addressing in this story still relevant to us today? And how can we deal with that, and how can we design them? So with new products coming out every day that promise to integrate our learning, living, as well as sort of our social interactions, essentially what we're up against is we're moving into a living space that becomes an all-encompassing interface. And this is something I want to explore further in this talk. So there's no denying that machines or computers are much better at performing certain tasks than their human counterparts. So this is a picture from 2011 when the IBM version of artificial intelligence, which is a supercomputer called Watson, took part in the game of Jeopardy and absolutely destroyed his human competition. The ability to factually compute or logically compute large amounts of factual data just made that there was no human that could compete against this technology. Before that, Watson had already proven himself at the game of chess, and more recently did the same thing to the more complicated game of Chinese game of Go. So another thing that technology is really good at is performing these repetitive and enduring tasks. So these robots on a production line, on a car production line, welding robots, they can, as long as you feed them power, they can continue their work indefinitely and basically produce much better results than any human could ever hope to achieve. So it speaks to common sense that if robots or machines can perform tasks better than humans, then why not outsource them to them by automating our tasks and thereby freeing up the time for ourselves to worry about other things. Now, this is industry, but of course the same applies to the homes. I mean, we've become so used to our laundry machines, dishwashers, and microwaves that it's already quite hard to imagine that these tasks used to take a real amount of effort and actual physical work. Now, the next step in this phase, logically, would be to increase the level of autonomy and agency of these devices by now integrating them with the latest advances in computation and sensory technology, and thereby make them smart. So there's a lot of talk going on about smart devices. Take a thermostat, for example. A thermostat is a good example of a device that is already quite ingenious because it's much better at measuring the temperature than any human can and switching on the heating at just the right time to make it super efficient. But this thermostat, which is called the Nest, is the sort of evolution of that. It's called a learning thermostat. So this thermostat doesn't only switch on the heating when the temperature drops below a certain point, but it also takes into account other environmental factors. So it has different sensing technologies that, for example, allow it to check if there's actually someone home and it's not turning on the heating for no reason and thereby wasting energy, for example. Furthermore, by connecting it to the internet, you can control it from your phone. But especially interesting is the fact that it has advanced software. So it starts to learn your behavior, it starts to learn your schedule, allowing it to autonomously switch itself on right before you get home, so you never enter a cold home. While thermostats and smart devices can certainly increase the comfort in your home, the smart cars actually have the potential to also save your life and solve traffic jams at the same time. So robotic cars have a lot going for them because 9 out of 10 accidents are caused by direct human failure. So if we hand over the decisions we make in the car to the machine, that could actually save a lot of deaths and injuries. However, of course, this technology is a lot more complicated to implement and therefore also a lot more risky. We need to really consider this, but if implemented properly, it sort of shows where this technology could go and how it could impact our lives in very intriguing and interesting ways, but also forces us to reevaluate what the quality of our lives are. Now, when we talk about smart technology, and I briefly mentioned this before, we don't talk about a singular technology, but rather we talk about a technological framework that combines different sensing, computing, and tracking technologies into a sort of all-encompassing framework that you can that allows you to access your virtual information more easily and more freely. And the father to this idea was Mark Weiser, when in 1999 he introduced the ubiquitous computing paradigm. So Weiser had observed that computers were getting increasingly smaller and increasingly cheaper. So it was logical to him that computers would eventually become so small that they would basically disappear, and so cheap that they would become practically free. Opening up this idea that computing could basically be anywhere. It could be embedded into all kinds of everyday devices. So rather than having a focus on a fixed interface like this bulky computer at the time still, that you had on your desktop, it could be integrated into tables, into chairs, into walls, all the stuff we were living with for years now. And by doing this, it would allow us to freely access the benefits of our digital lives almost everywhere. Now for Weiser, that didn't only mean that it was like a technical challenge, but he also saw this as an opportunity to redesign the way we thought about computation. And to have technology act more as a sort of invisible and discrete assistants that could move into the background and only make themselves luminal again at the point where you actually need them. And I think a film that depicts this really nicely is the film Her by Spike Jonze. It came out in 2013. I expect many of you will have seen this film. If not, do go and see it. It's really a must-see. And in this film, what is interesting is that the future home as it is depicted is actually more like the home from the past, because all the technology has been moved into the background. All the technology has become discrete. So there are a few desktop computers left here and there, but the rest is sort of moved into the background, and the ones that actually do exist are designed in a very substantial way. And in this case, in this image, the whole interface is reduced to just that single little earplug in the ear there. So very unobnoxious. What this means is that the technological dream here is to combine this idea of ubiquitous computing, everywhere, always computing, with more advanced software agents. So agents that can compute complicated human speech modalities like gestures or human talk and respond to you in a natural way, thereby creating this idea of an intelligent interface. So this, for example, is a concept by LG that is a smart refrigerator. You can't avoid them, apparently. That allows you to basically text to it to ask if something is available, and it texts you back in natural language. So from this we can begin to create an understanding of what we're talking about when we're talking about smart devices or smart technology. So the first is built on the ubiquitous computing paradigm, and it means that computation is everywhere and it's embedded into the environment, so in objects. The second is that these computers are outfitted with sensory components, that they're able to become context aware, to know what's happening around them. Then finally, they should be able to compute what is happening around them and make a decision based on that, and thereby switch on or react in physical space, so to control a certain system or to control an object and basically affect our immediate surroundings. And once these systems could become increasingly advanced, they should even be able to anticipate on our needs. So they would even consider our preemptive desires, so the desires that we aren't even realizing we have yet, and act upon them beforehand. Now there's a few strange things that are going on in this field of smart technology, and especially in reference to the smart home. And the main thing is that these visions never change. The vision is still the same as it was maybe 100 years ago. So for example, this is a newspaper clipping that is from 1977, in which the future home, the home of the future is discussed. And in this case, it promises that the housewife will be freed of her duties by integrating them more easily and accessibly with the help of this central console that integrates all work and leisure and pleasure. And this is a video that's more recent. It's from 2015, and this is how Microsoft imagines our future for 2020. Now, of course, the technology that's presented is a little more slick, it maybe looks a bit more modern, but actually the premise of what it's presenting is still the same. It's still to implement this technology and make this home this very efficient place that takes away all this, and with a smart technology takes away all the stresses that we have to deal with when we're talking about house management or homekeeping. And this is sort of interesting because it means that the complicated interactions that we have in the home, they're being reduced to these quantifiable numbers where we're supposed to value them in terms of efficiency and productivity. And this allows the skeptics to easily dismiss all of the benefits that smart technology could have, because you can easily say that a house is not a machine for living, nor is it an assembly of tools that allow you to survive life, but rather it's this sort of emotionally charged cradle for living where all of the interactions have a complicated social structure and complicated emotional attachments. And this project, which is called the Precision Toaster, is a speculative proposal by Onkar Kular in 2002, and he makes us question or reassess this observation with efficiency by placing it firmly in the home. So this is a toaster that would come with 24 slices of pre-sliced bread, so that it allows you to calibrate the toaster to basically allow for future perfect toasting. And I think it's very efficient in its subversive approach to make us wonder about where our physiological and psychological comforts sort of run over into obsession. Another issue that we have with the visions on the future home or this future smart technology is that they're sterile. they always present us with this massively clean slate where nothing ever breaks, where no one is unhappy. There's always this idea of a general user that is, in most cases, white, young male, that's well earning and also technologically savvy. And it doesn't really stick with the complexities of implementing this technology. It doesn't feel natural to us because we're used that technology is not working, is always working in the ways we're supposed to. So this film by Nicholas Nova, which is called A Digital Tomorrow, sort of investigates how smart technology could actually pan out if it's implemented improperly.
Call Gerardo.
Name unknown.
Call Gerardo.
Name unknown.
Call Gerardo.
Calling Gerardo.
Hello?
Hey Gerardo, did you call?
Yeah, are we still on for coffee?
And then, of course, finally, there's the issue of control. So if we hand over the responsibilities of managing our lives to systems that we cannot, that can compute and reason in ways that we cannot humanly understand, that implies that there's a power differential between the object and the user. And it means that the agency of the user could be reduced. And this also means that the users could become design resources for the people that are actually have the technical literacy to implement and design these systems. And I quickly want to talk about this because in 1986, Langdon Winner famously questioned if objects could be political, if they could have intrinsic moral values, by analyzing a number of bridges in the state of New York. So the parkways provide access to the beach, and by implementing these bridges that were specifically designed to be too low for the public transport to go underneath, the architect Robert Moses actually made sure that the lower class and colored population of New York would have no access to the beaches, and thereby the beaches would be reserved only for the privileged few. So looking at it from this perspective, it means that technology is not a neutral instrument, but it can be intrinsically politically charged. And thereby you can assess it in moral terms, so it can be morally good or morally bad. However, the question is, who is responsible for designing this morality? And moreover, do we trust them that they act in our own best interests? So I'd like to show one final example, and this is an example that was created by Dunn and Raby, designers from the UK, in which they imagined a new or possible alternative futures for the UK, and the project is called United Microkingdoms. And specifically, this part of the project looks at a possible digital future where everything is governed by algorithms, and we all drive smart cars, and therefore the whole, basically, we don't need roads anymore, just a big sort of tarmac where these cars can drive freely because they can avoid collisions intelligently. However, the way they sort of interact with each other is not only governed by safety, but also by market values. So this video sort of shows different ways in how this could happen. So for example, if economic values are also playing a role, then it means that the ones that are paying more, that means that the cars could be quicker or safer. They would basically challenge to think us about what the other values are that car manufacturers could embed into those systems. So to wrap it up, I've talked about how this technology can potentially change the ways in which we live, because it becomes clear that as we enter this age of miniaturized computing, the physical world and the digital world will begin to interact in even more and more diffuse ways, and they will definitely have a very concrete impact on our physical existence. And it goes almost without saying that without the proper design, this new technology can basically be terrifying. So this is why I want to emphasize that as designers, we don't only need to worry about how we can technologically implement these systems, but we should also become more or better trained at using our moral imagination to test our technologies by creating scenarios that use complicated users, extreme use cases, and very uninhabitable extreme environments, for example, to test what would be a good solution. So the idea here is to steer clear of a mindlessly connected future in favor of one that is much better in tune with our actual needs and desires. And I hope that we will see many of those examples here today. Thank you very much.
Thank you, Frank. It's interesting, and I think we could talk for hours about the subject. But there's an important thing. Last night, the CEO of IBM, she told about the IBM Watson that you showed in the presentation, and she says, in 5 years, Watson AI will be behind your every decision. Is that a terrifying promise, or do we trust technology enough to let it make our decisions?
Yeah, so I think the idea of trust is interesting. Like, trust implies that you build trust. You don't sort of have trust immediately when you meet another person. The thing is that you know from experience if it makes valuable decisions or not. But if you're influenced behind your back and you have no literacy to actually peer inside of the device, to know why it's making certain decisions, or the reasoning is so unhuman that you can't possibly grasp how it's working, that becomes complicated because there's
that is the case, right? Because we don't know how it is working.
Exactly, and there's also no way to object it. However, there is of course a part to play for the user as well, because you still opt in or opt out. Like you have to actively decide whether or not you integrate this technology into your life.
But is there still a way we can opt out of stuff?
I think so. I hope so. I'm not 100% sure. This is what we need to talk about. But I mean, in this case, I still think there is. Yes.
Because is that your experience also? If you talk about these developments, and then there's one part of the room, maybe it's 90 or 95% in here, but let's say general public, that gets very excited. But there's always a few people that say it scares me. I don't trust it. Who programs the computer? Who says the advice is completely neutral and based on what?
Exactly. I mean, this is why I'm saying we should design more complicated scenarios, because that way we can move this decision making into the public realm before it actually becomes a product. This way we can collectively question what the real desirable outcomes are, because otherwise we have to leave it up to the engineers alone, who might be much more enthusiastic about the technology, much more optimistic usually about the technology. This is based on this idea of very specific understanding of good design that doesn't create doubt or disharmony in the lives of users. Whereas I think we might need to reconsider that and try and maybe introduce this disharmony or doubt so that we can actually come to more novel and interesting applications.
So that's also a call to the designers, right?
Exactly.
All right.
Yeah.
Thanks a lot.
Thanks so much.